Oh my God. Voice, some issue. I think first disconnect, then connect. Okay. Yeah, everything is fine now. So after long time, I'm starting a class teaching for you, and today I am giving you some informative things about complex analysis. So current now, I am teach you something related to complex analysis. Just for current time, just review of some content here. So in complex analysis, first thing is that you know the basic things, because basic things are very helpful for you. Okay. And so now in this section, I'm going to teach you some basic concepts about complex analysis. So again, I am repeating this word. So now in this section, first in section algebra of complex number, I will teach you something complex number, triangular inequality and its application. This is a reference book like HS Kasana. Okay. So this book is very helpful for CSIR NET exam. And I think maybe some concept asked in your GATE exam also. Okay. So, and basic for BSc and MSc student. So here I'm going to teach you some topic. Now today time I'm tell about some concept, content. So here is some concept related to your complex number. So first thing is that in algebra of complex number, there are 6 sections. In first section, what is complex number? And in second, triangular inequality and its application. Third section, polar and exponential form. Fourth section, power and roots. And fifth section, reasoning complex plane. The next one is extended complex plane. So now today I am begin the algebra of complex number. So it is only book. Now explain you book. So here some save your time for writing some content here. So now first thing is that uh, keep in your mind. First thing is that now here is some list of symbols related to this book. So now the n represent your set of natural number, I is your integers, q is your rational number, r is your real number, and r is what, that is the two-dimensional, I think x and y be the element here, and x belongs to r and y belongs to r. That is the all order pair of real numbers. Okay. Now see the basic things. I think everyone know about this. This is the complex number system. Here I am representing some value. Standard like z. Z will be your x plus iota y. And here x is your real part of z. And iy be the imaginary part of z. So this is the real will be your x and imaginary will be your iota y. Okay. And then next one is your modulus section. In modulus section, that is the representation of modulus section. Maybe here you are seen, this is your modulus z. So maybe it may be right like this, x plus iota y modulus form. And now the argument plane, that is the representation of some radian values, that is theta. Then z is equal to r to power I theta. It is a polar format. I think, Euler form. So maybe these are the your argand z. Next one is what is simple argand. It is the values of theta maybe minus pi uh, less than theta and greater equal to your lesser equal to pi. And now next one is your non-zero integer. So maybe represent you the non-integer value will be represented like this. And I plus this is a positive integer. R plus this is for real number, positive real number. And here is the neighborhood section. When you have some delta neighborhood and maybe the content related to neighborhood, it's maybe represent like this. And delta z0, z mapping for Z minus Z0 is less than delta. This is your neighborhood, and maybe you may be represent like this. This is your delta. Delta is your very smallest number, I think. Here is some deleted delta neighborhood of Z0. These two things will be help you for something, solve some, I think, complex number questions, CSIR NET problem. Okay. And delta S will be the boundary of the set S, and S bar is the closure of the set. S and S bar here is the closure of set. D upon omega, this is your domain. Okay. Maybe in your last class, here is some mapping form. F. This is your 1-1 mapping. Maybe consider it is your 1-1 mapping. So every image have some pre-image you got. So here, this is the representation of some mapping. And in first section, when the function goes from A to B, this is your domain part, and B is your codomain. Okay. And then this is your domain. So maybe it is represent like this. And supremum of S is the least upper bound, in your when you are move on the uniform continuity, this section, and maybe you are from any monotonic sequence or any something concepts related to your supremum and infimum, so bounded function. Okay. So basically these two section will be covering your bounded function. Bounded. Okay. If your sequence is bounded, then maybe two things are have, that is infimum and supremum both are present. Then you say that the function, yeah, this section is your boundary. So here is some u is equal to this is two things are basically read in analytic portion maybe. And this is not your analytic, but these two symbols comes your analytic section, and both in your complex plane also. These are the real component of f is equal to u plus iota b, and here is your imaginary component of f u plus iota b. And next one is your gamma. Gamma t is equal to represented as xt plus I by t, and this is the path in complex plane. And next one is your this symbol for implies. Okay, implies by, and here is both imply if and only if. And in short form, you write like this, if and only if. Okay. Maybe some differentiate about the upon delta z. This comes gives you, and when you are asked about the conjugate, then this one. And here is the fz. Fz is your del f upon del z, and fz bar is del f upon z bar. Here is ln x, that is natural logarithm, and lim supremum, it is your lim supremum, lim infimum. Okay. Means limit superior and limit inferior may be limit superior your and limit inferior. Okay, these are the two symbol basically used in limit in concept related to limit superior and limit inferior. This is the symbol of pair exist, and here is your line segment joining Z1 and Z2. So these are the basic things, I think. And here is the gamma 1 plus gamma 2, the sum of parts gamma 1, gamma 2. E to the power z is your exponential function of z. Log z is ln z plus I argument z, that is your logarithmic function of z. N is some principal logarithmic function of z. Okay. Eta, gamma, and alpha will be winding number of a path gamma with respect to alpha. Here is a residue. For in a residue section, the symbol may be represented as residue S2 is Z is equal to EFZ, and where Z is equal to E or A. Here is the principal of the shortest form, and here is the big O, the small O will be represented the operation, or basically used for operation. Fp is the Laplace transform of F. NR is the number of zeros of F in Z, which is less or equal to modulus Z, which is less equal to R. Here is rho, which is used for the entire function, order of an entire function, and is sigma, type of an entire function. Okay. Now, come to the next part, which is your algebra of complex number. So basically, in this section, algebra of complex number maybe uh, it gives you some basic idea about fundamental concept of complex analysis. Okay. So now, when you have some field of real number, maybe written like this, that is the equation x square plus 5, which is equal to 0. Okay. Um, I think this equation have no solution because when you are try to solve like this gives you minus 5 and x is equal to under root minus 5. So maybe this have no solution. Then the requirement of complex number here. What? The requirement of complex number here because when you are go for multiple with minus I and root minus 1 which is iota. So the requirement of complex number here by using some imaginary number in algebraic form. So in algebra of complex number, these chapters told about how to apply the iota formula, and this will be help you to understand what is complex number and use a complex number uh, in your mathematical solution. So there is the equation had no solution. So to find such solution, the real number system has been extended to set of complex number. Okay, Euler, this symbol by used by Euler. Euler introduced this symbol iota. Okay, and iota square will be equal to -1. Okay, and then and z is equal to x plus iota y. Okay, and some introduce about z is equal to x plus iota y. Okay, and x used for real part and iota y will use for imaginary part. So your x is equal to what? Real part of z. Okay, here I am right. Z is equal to x plus iota y. Okay, your real part of z is x and imaginary part of z is iota. These two things are used by Euler and introduce some concept about complex analysis. Now here some complex number. So maybe you understand this. Now come to the part. Yeah, here is something written about the same things. Okay. Now move on the next part. That is the consider some R square. R square is nothing but it is the multiple of two dimension, that is R square. And here you take some element for x and y, where x belongs to real and y belongs to. I think I got some message. Okay, no problem. Come to this part. Yeah, here is the order pair of real number x and y defined by R square. Take two elements. These two elements belong for real number. Okay. Now order means what? Ordered means x comma y. Okay. And y comma x are different unless x is equal to y and x comma y are non-zero element in R square. Means at least one element member is the order pairing non-zero. Okay. Now come to the next part, which is the defining the operation of addition and multiplication in R square. So first thing is that when you have some number x1 comma y1 plus x2 comma y2, when you move from addition of these two operations, when you apply here the addition part, then you got x1 plus x2, and normally, yeah, these two things. Okay, I'm not able these two things. Okay, first thing is that apply like this when you for go for addition, then x1 plus x2, okay, and y1 plus y2. And when you are go for the multiplication, multiply x1 in x2 and y2 as well. Then from y1, then multiply with those two sections. These are the both the operation of addition and multiplication in R square. Okay. These are the part of commutative group, and you know it very well. What is commutative group? Commutative group in group algebra already you teach you your teachers, but I am able to. When you have some number that is a and b, okay, then you got some b comma a, and these are the closure property. And now associative part is like this: b plus c. Okay, then move on the. Here is, I am written here A, then this is your associative part. And now the commutative part. With respect to addition, then you got the set of all non-zero element in R square. These are the form of commutative group with respect to multiplication. Now the reader can prove the statement easily now. So your part is how to prove this. So here I have some proof related to forms of field under addition, multiplication. Okay, here is the 1.2 part respectively. So go for the first thing is that for addition section, these are the commutative group. And now next one is here commutative group for the multiplication portion. Okay, you know it very well. These are the two things here I'm say about now addition and multiplication as well. So here in first section, R square plus when you are go for addition section, then with the commutative group, and you prove like this. When you have some portion like this, these are the so the distributive over plus and addition. So here you observe this. Here is some apply here the addition of two numbers to R square number. Here is the one thing is that for the multiplication. Now, when you solve these two things, you got these number. And here, when you common the same things, x1, y1, x2, y2, then x3 plus x3 comma y3, it gives you something like this. Okay. So when you are take your common, then you got the same things. Okay. Now these are the commutative, but it distribute over. It shows that multiplication is distribute over addition. Now similarly, you can argue with this type of things. Okay. Now come to the definition part. Okay. So definition tells about some complex number which is defined for the ordered pair like x and y in a real number. In real number, and here is representation that is your z. Z will be x comma y. So these are the ordered pair. So here is some rule addition with multiplication. So Z1 plus Z2 is your x1 plus x2. And now the part is for multiplication, you got this. These both are the commutative things. Already commutative group. Already you see here, these are the R square forms of commutative group with respect to addition and multiplication. So these two things you got here. This one is Z1. Z1 is your x1, y1. Z2 is your x2, y2. And two complex numbers Z1 which is your x1 y1 and Z2 is your x2 y2, and when you are equally you got x1 equal to x2 and y1 equal to y2. These are the non-zero, at least one of the elements x and y is non-zero. So next thing is that first thing now here is some more part. It is trivial to prove that any real number a and b we have something like this. So when you have some two element, that is two ordered pair, one is your a comma 0 and b is your b comma 0. Now when you go for the addition, these are section you got, and when you go for the multiplication, you got this. These are the motivated ideas of complex number forms of the order pair of a comma 0. Okay. Now the next part is the identification gives you the real field as the subfield of complex field. Now move on the next part. Here is some more imaginary unit. So imaginary unit is basically iota. Iota defines as iota. Iota is your 0, 1. Already written here. I am not going to write this. Now come to the I square. I square is equal to -1. So proof of I square, when you have iota, the number is 0, comma 1, already you have. So go for the multiplication portion here. When you go for the multiplication, you got -1. So this is for iota square is equal to -1, and must be remembered. I think directly you can apply in each and every part of question, that is iota square is equal to -1. Okay. Now come to the next part, that is your question number 3. Ah, campus. Now come to the next portion. When you have some every complex number z is equal to x comma y, so it can be written like this: z is equal to x plus iota y or x plus iota y, where x and y are real and imaginary part of z, and denoted by real z and imaginary z. So proof for this, apply here x comma 0, 0 comma y. You got x plus iota y. Okay. So here is some basic things about your exam. So maybe first thing is that these are the basic portion. I think you cannot read in your standard textbooks, but here I'm able to explain these things because HS Kasana is very nice book. Okay, so try to read write like this. Here is your z is x comma y. Okay, now take x comma 0 for order pair for x, and for y 0 comma y for y. Okay, so when you here x comma 0 plus 0 comma 1, and next thing is that y comma 0, which is equal to x plus iota. These two things we have now. Similarly, z is equal to x plus iota y. So iota is the definition first for addition and second for multiplication of complex number, and may be translated like this: x1 plus iota y1, x2 plus iota y2. So x1 plus x2 plus iota y1 plus y2 here. Then for addition section, okay, when you go for the multiplication, you got this. Now, for now onwards, x plus iota y, x plus y iota, that is same meaning, okay? So z is equal to x comma y is your order pair. Now, when you are go for the define, you got the linear symmetry equation have the unique solution, that is your a is equal to x upon x square plus y square, and b for y upon minus y upon x square plus y square. Okay, so z inverse equal, so z inverse is your x upon x square plus y square minus y upon x square plus y square, and z inverse is your x upon x square plus y square minus iota y upon x square plus y square. So here is some more complex to be a field. So these are the very basic properties. Okay, I think there are 7 properties here. First is your additive identity is unique. Identity. So in group section already you study na, what is your additive identity. I think when you have some additive identity, that is, take one element is A and second one is 0. You got A na? Here, 0 is your identity. And here say that identity is unique. So Z is equal to 0 and here is 0, 0 maybe, right? Now move for additive inverse. Additive inverse, when you are add for this, okay, this is your additive inverse. No, yeah, I think you got this. Okay, 1 upon a, now multiply with a square plus 1 upon a, and we are multiply with this, you got a plus a inverse. Okay, these are the additive inverse. So this is your unique part. Now the left cancellation law and right cancellation law. So here is some cancellation law hold for addition. These two things for cancellation law holds for addition. Now multiplicative identity, when you have some element in group section, then you multiply with 1, you got only a. This one is your additive multiplication identity. So in complex section, z is equal to take 1, and here is 1 comma 0 is unique. Now next thing is that when z not equal to 0, then multiplicative inverse is unique. Okay. Now next part is your when z not equal to 0, then z multiple with z2, z1, which is equal to z2, and z1 z, z2 z, z1 equal to z2. And 7 section z1 z2 equal to 0, then either z1 is equal to 0 or z2 equal to 0. Now when you are go, these are the basically the properties. I think here some properties about in C to be a field R or no. So these are the basic idea about when you got some field, then you apply like this. Additive identity is unique. Additive inverse is unique. Cancellation law hold for addition. Multiplicative identity is unique. And multiplicative inverse is unique. So these whole things you give you some idea about how can you say that the consequence of C is to be the field R given. So these are the basic properties. Here are some 6 and 7 portion already we have. Now move for the subtraction. So subtraction, this is the inverse process of addition. Z2 is subtracted for Z1. So these are the subtraction portion, Z1 minus Z2, Z1 plus minus Z2, X1, Y1. Okay, this is your subtraction. Now move for the division portion. When Z2 not equal to 0, because when Z2 is 0, then it gives you 1 upon 7, 0 is which is equal to infinity now. So Z2 is not equal to 0, then it is a form of PYQ type rational number. But here as you are saying about some complex things. So Z2 not equal to 0, then division by Z2 is defined as Z1 upon Z2. So you maybe write like this, Z1, Z2 inverse. In this way, Z1 which is equal to 1 and 1 upon Z2 which is written like this, Z2 inverse. Simple things, na? When you got some x which is equal to 1 and 1 by x, which is written simple x, and here is your x inverse. Okay. So here is when you are seeing complex format, then you see here these two things. Now, these are the simple results. Okay. Z1, Z2, whole inverse. Then you got Z1 inverse, Z2 inverse. Since Z1, Z2, Z1 inverse, Z2 inverse, which is equal to 1, and Z1 inverse, Z2 inverse, Z1, Z2, which is equal to 1. So 1 upon Z1, Z2, which is equal to Z1, Z2 inverse, which is equal to your Z1 inverse, Z2 inverse. Z1 plus Z2 upon Z3, which is Z1 plus Z2, Z3 inverse. Z1, Z3 inverse and Z2, Z3 inverse, that is your Z1 upon Z3 plus Z2 upon Z3. Now, R square has been identified as C provided addition and multiplication of elements R square are defined by 1 plus 1, 1 dot 1 and 1 dot 2 for definition other than 1. We shall not permit R square to be identified by C. Note that real part Z1 plus real part Z2, which is equal to real part of Z1 plus Z2. And here, when you are going for the imaginary part, this is the imaginary part Z1. Now, next thing is that geometric representation. These are the, now I'm open. Some, I think OneNote is not working here, so I am open one another tab. Nah, no need to open another tab. Okay, simply things, simple things. I can teach you some geometric representation of complex number. First thing is that actually here is some space or not. Yeah, here is some geometric representation. So these things are many Z. This is modulus of P point x-axis, y-axis. And here the imaginary part, okay? And here is your real part, okay? So the complex number can be regarded as ordered pair of real numbers. That is z is equal to x comma y. This is your ordered pair. This form complex number suggests that z can be represented by a point P, okay, whose coordinates are coordinates x and y, okay, relative to rectangular axis, that is your x and y. So for each complex number, there correspond one and only one points in the xy plane conversely, okay. So this plane is called complex plane or Gaussian plane or Argand plane, okay. These planes are called as what? Complex plane, complex plane or Gaussian plane. And next thing is your Argand plane, okay. So the representation of complex number in place of called the, these are the your Argand diagram, okay. Now come to the this section what, yeah. So z is your x plus iota y is the order pair, clearly the set of x0 correspond to x6, which is called real axis, and here is your imaginary part correspond to imaginary axis. So everything will be fine for you. Everything is fine. So identifies the complex number, that is your 0 is equal to 0 plus iota 0. This term is z plane, w plane, depending on letters. Okay. Used to denote generic complex number. So non-negative numbers, modulus z, called the modulus or absolute value of z. So here is one thing is that I have some note about some modulus, okay, vectors and moduli. I think this section help you a lot for understanding the vectors and moduli type of function. Now, in this section only, I am tell you the distance of complex number. These are the distance for complex number and maybe represent like this. So, infrequently use the following simple inequalities. Modulus will be represent like this. These are the real parts and real z which is less equal to real z. Here is the modulus, okay, for imaginary parts. And here is your Argand diagram. Now next thing is that the conjugate. Conjugate is very important. So it is nothing but when you have some x plus iota y type number, then conjugate section is basically 1 minus apply here, then you say that this is your conjugate. So in complex conjugate denoted by z bar and z bar which is equal to x minus iota y, and when you are go for the order pair, this is your x comma minus y, minus y. So z bar is the mirror image of complex point and z into the real axis. This indicates that z is equal to z bar, z is purely or real number, and z port bar is equal to z. So these are the following consequences of the above definition. So maybe if you have some z plus omega, then z bar plus omega bar, and here is always z omega bar, z omega, z bar omega bar. And for C section, z plus z bar, which is equal to 2 real z. And for imaginary part, z minus z bar, which is equal to 2 iota imaginary z. And here is your z bar is real and positive unless z is equal to 0. And here is your f z minus w is. And we are going for the division section, then z bar upon omega. So these are the entirely equivalent way of representing a complex number. Z is equal to x plus iota, y is to the used to the vector. And joining the origin O and complex plane with the point P is equal to x comma y instead of using point P itself. So we discussed the sum and difference of two complex number as well. So in complex, for going for the sum, since the complex number z is equal to x comma y, represented by vectors. Okay. These are the basic diagram. Yeah, here is your section. Maybe say about something factors and modulus. Okay. Yeah. So these are the basic diagram for sum and difference. So here is using Z1, Z2. These are for summation, sum. And here is your the diagram for difference. So these two diagram, one is for sum and second is for difference. Okay, now go to the next section. Yeah, here is the only, now I have some example about this. So here the example say that under that condition on complex constant alpha and beta, with the quadratic equation z square plus alpha z plus beta which is equal to 0. Here is A is your real roots and B is your one of the roots on the unit circle, and unit circle is your z modulus z which is equal to 1. One thing is that when you are go for unit circle, so basically in unit circle, z which is equal to 1. So this is your quadratic equation. So convert this quadratic equation like this, x square plus alpha x plus beta which is equal to 0. And next thing is that the question say that under what condition on complex constant alpha and beta will the quadratic equation, when first thing is that real roots and second thing is that one of the roots of the unit circle modulus z which is equal to 1. So suppose these are the quadratic equation has real roots. So say that z is equal to x, then x square plus alpha x plus beta which is equal to 0, and x square plus alpha conjugate x plus beta conjugate which is equal to 0. So examine for x. So now when you are go for the addition portion, no. Basically here they using some quadratic explanation, quadratic equation explanation. So this is nothing but beta minus beta square, or these are the standard format for solving a quadratic equation, which is your, I think, x minus y square alpha and x minus y. And second thing is that y conjugate, and here is your x minus y, x minus x conjugate. And then next one is beta. Here is your x minus y conjugate whole square which is equal to 0. These are the basic, I think, already you learn in solving some problems related to quadratic equation. So convert this is into this format. So here is your x will be your y. What is your beta minus beta conjugate is whole square minus alpha beta minus beta conjugate alpha minus alpha conjugate plus beta alpha minus alpha conjugate square. So now these are the required condition. Now the required condition is your this. Okay. Now second part, z1 to be the root such that modulus z1 is equal to 1. So z1 square plus z1 square plus alpha z1 plus beta which is equal to 0. And next thing is that When you are go for the Z1 which is equal to 1 implies Z1 bar which is equal to 1 multiply by Z1 bar we have. So after conjugation, Z1 plus alpha plus beta Z1 which is equal to 0. And the second thing is that Z1 bar plus alpha 1 plus beta bar Z1 which is equal to 0. So eliminating Z1 bar for this equation, so you have obtained 1 minus beta mod beta square Z1 alpha minus alpha bar beta. So the condition says that modulo Z1 which is equal to 1, as the required condition as alpha minus alpha bar beta which is equal to 1 minus modulus beta bar square. So as yet we have not defined a relation of the format from Z1 which is less than Z2 if Z1 and Z2 are arbitrary complex number. So suppose we were able to define an order relation which is less than C. So satisfy some axioms here. First thing is that first axiom say that if Z is less than W, then for every Z0 we have some Z plus Z0, Z plus Z0 which is less than W plus Z0. Okay. And in second part, when you have Z is greater than 0 and W is greater than 0, then ZW is greater than 0. Okay. And if Z is greater than 0, these are the two things. So Z is positive. If Z is less than 0, then Z is negative since iota which is not equal to 0. So either iota is greater than 0 or iota is less than 0. Let's assume iota is greater than 0. This implies that iota square is greater than 0 or minus 1 because the value of iota square is equal to minus 1. So which is already seen your in previous time, I think basically 5 to 10 minutes before. So minus iota is less than 0. Also, if iota is greater than 0, then minus iota is greater than 0. I think already these are the basic example related to your under what condition complex constant alpha and beta will be the quadratic equation. So now these are the basic problem related to this U for SW. Go and solve this. Now next thing is that triangular inequality and its application. So basically these things are very important. So now uh, first thing is that understand Z square which is your Z and Z conjugate. So let Z and W be the two complex number, Z and W be any complex number. Then modulus Z which is greater than 0 unless Z is equal to 0. B section when modulus Z conjugate, then it gives you minus Z conjugate. And C section Z omega which is equal to Z on W. And D section Z upon W which is your Z upon W. This section Z plus W which is less or equal to modulus Z plus this is your triangular inequality. So basically in this section, I will going to teach you some Euclidean space type format and some uh, triangular inequality. I think portion maybe some here is nothing more given, but I have some more things about this. Okay, these are the basic properties only. So in triangle inequality and its applications, wait for 2 minutes. Yeah, in this section, I think these are the basically triangle inequality. And now here is the proof. Yeah, this is your squares inequality. And next thing is that find some upper bound of the function and many more questions. So here is your something. This is your part. That is your modulus z, which is equal to 0 unless z is equal to 0. So come to the this note. A, B, C, the direct consequence of definition for this z modulus z square, which is equal to z dot z bar. And for D section, z upon w bar, which is equal to written like this. So must we apply here modulus z, which is equal square is equal to z and z bar. So these are the like this. So this is your modulus z upon w bar. Then when you are going for the addition section, now go for this triangular inequality. So it gives you this. So go in book and watch the proof. Okay. Now next thing is that for most important thing is the here the squares inequality, because in many complex question CSIR NET question ask about what is the squares inequality and some problem related to this. So basically in this portion, I am going to teach you some this proof number. So basically in this section for every real number x, this is your squares inequality and you written like this. Okay. That is your summation k is equal to 1 to n modulus zk x plus wk square greater or equal to 0. Then this is your greater or equal to 0. Okay. Apply here. Now ax square plus b, yeah, this is your upper bound of that function. So this is most important things. I think everyone know about this and need to know about the upper bound of the function, how to find. So in this section, first thing is that try to solve z square minus z minus 6, which is equal to 0. So first thing is that solve this portion first. This is your basic quadratic equation. So try to solve this first and then apply the um, further calculation. So here is your z square minus z minus 6. That is when you go for the quadratic portion, when you solve this, then you got z plus 2 z minus 3 and here is z square plus 3, which is less equal to what? Modulus z square plus 3. Here is modulus z minus 2 modulus z minus 3. Then I multiply both these things and then 1 plus 3, which is basically equal to 2. So I have CSIR net problem and I am going to solve in this section, yeah, because I have no more space. Okay. So first thing is that try to change this section. Where is one more? Now I'm going to solve some problem related to this topic. Okay. One more time. Yeah, here is your concept. I think everyone have visible this portion and try to change behavior. Uh, yeah. So already you know the concept of something related to this. So I have problem. Okay. That is your every time ask in your exam. Wait for some minute. Yeah, here is your question. Some question related to what I am. going to give you, okay, basically type one question here for complex number. Z1 and Z2, which following is always true. Option A, modulo Z1 Z2 greater or equal to Z1 plus Z2. B option, this is your standard requirement. I think you understand easily. And the next thing is that option number C, where I multiply these two things. This is your Z1 Z2, which is equal to 2. And option number B, so how to solve this question? First question. So this type of question, okay, this is the, I think option B is correct, but how to say that this option is correct? So for reverse triangular inequality, for reverse triangular inequality states that वो इस क्वेश्चन को कैसे आप सॉल्व करोगे वो नहीं बता रहा, यही तो है। अगर डिफरेंस लेते हैं मॉडल का तो क्या मिलता है, Z1 माइनस Z2 मिलता है, ओके। सो Z1 माइनस Z2 टोटल इक्वल तो क्या हो जाएगा, तो यहाँ से प्लस Z1 माइनस Z2 हो जाएगा, ओके। सो ये क्या है आपका बेसिक रिवर्स फॉर्मेट है ना ट्रायंगुलर इनइक्वालिटी। सो ट्रायंगुलर इनइक्वालिटी सब लोग करते हैं, लेकिन तो उसका रिवर्स भी आना चाहिए, ओके। ये मेरा कंसेप्ट है। एक और क्वेश्चन इसी के बेस पे समझते हैं। क्वेश्चन है जो CSIR ने टाइप किया है। क्वेश्चन है जेड इक्वल टू दिया हुआ है एच प्लस अल्फा एच इनइक्वालिटी correctly relates modulo z to x and option are given here. Option A say that modulus x plus modulus y less or equal to indirectly modulus x. Option B is here indirectly modulus z less or equal to x plus modulus y. And here is your option number C. It is modulus x modulus y, which is equal to modulus z. Option number D say that none of the इस क्वेश्चन को कैसे करोगे ऑप्शन। सो ऑप्शन तो इसमें मैं बता देता हूँ कौन सा करेक्ट है, ऑप्शन ए करेक्ट है, लेकिन कैसे है वो समझता हूँ। ये क्वेश्चन है, समझने का प्रयास करें। सो इस टाइप के क्वेश्चन में सबसे पहले क्या है कि सिंपल सा ये समझें, ये क्या है, अंडर रूट टू है। ओके। सो ये ऑप्शन कैसे करेक्ट है, तो समझ लो पहले क्या देखें। अ, देखते हैं। सिंपल सा फंडा है कि अगर फिंगर इनइक्वालिटी होता है एक्स प्लस वाई, ठीक है, ये डिवाइड्स करता अंडर रूट थ्री। सो क्या होता है, मॉडुलस जेड मॉडुलस एक्स प्लस मॉडुलस वाई होता, देन गो फॉर सेकंड प्लान। ओके। सो मॉडुलस जेड क्या होगा, लेस और इक्वल टू मॉडुलस एक्स प्लस मॉडुलस, एंड मॉडुलस जेड इज इक्वल टू एक्स प्लस अल्फा है। तो क्या होगा, ग्रेटर इक्वल टू हो जाएगा आपका मॉडुलस एक्स प्लस अल्फा। ओके। अगर मॉडुलस जेड लिखना होता सिंपल, तो क्या लिखते हैं, मॉडुलस जेड को लिखते हैं एक्स प्लस मॉडुलस रेक्टेंगुलर इनइक्वालिटी टाइप करेंगे। सो मॉडुलस जेड क्या होगा, यहाँ से एक्स प्लस अल्फा वाई, तो एक्स प्लस अल्फा वाई को इस तरह वाई बाई पार्ट में लिखते हैं, है ना। देन इस पोर्शन को आप क्या करोगे, इस पोर्शन को ऐसे लिख सकते हो ना, मॉडुलस एक्स प्लस आयोटा मॉडुलस वाई। ओके। देन विच इज इक्वल टू मॉडुलस एक्स प्लस मॉडुलस वाई। एंड आपको पता होगा कि मॉडुलस आयोटा क्या होता है, वन होता है। तो मॉडुलस आयोटा अगर इसका लिखा जाए मॉडुलस आयोटा में, जैसे मान लेते हैं इसको मैं मॉडुलस ले लिया, तो ये क्या हो गया, दिस इज योर वन। सो डायरेक्ट हम इसको लिख सकते हैं ना कि मॉडुलस एक्स प्लस मॉडुलस वाई लिख सकते हैं। सो क्या है ये, फॉर द फर्स्ट पार्ट के लिए ऑफ द inequality to use the arithmetic। अर्थमेटिक में या बोल सकते हैं इसकी ज्योमेट्रिक में निकालो। ओके। नाउ यहाँ से एक चीज मिलेगा आपको, है ना, एक चीज यहाँ से मिलेगा। सो ज्योमेट्रिक में इनइक्वालिटी में क्या बोल सकते हैं दैट, मॉडुलस एक्स का स्क्वायर प्लस मॉडुलस वाई का स्क्वायर ग्रेटर इक्वल टू क्या होता है आपकी, मॉडुलस एक्स मॉडुलस वाई। ओके। दस मॉडुलस एक्स का स्क्वायर प्लस मॉडुलस वाई का स्क्वायर क्या होता है, प्लस टू मॉडुलस एक्स प्लस मॉडुलस वाई लेस और इक्वल टू टू मॉडुलस एक्स का स्क्वायर प्लस मॉडुलस वाई का स्क्वायर इक्वल टू टू एक्स स्क्वायर प्लस वाई, और मॉडुलस एक्स प्लस मॉडुलस वाई का होल स्क्वायर विच इज इक्वल टू व्हाट, इक्वल टू टू मॉडुलस एक्स का स्क्वायर। सब taking the square root on both sides, modulus x plus modulus y less or equal to 3 by root 2 modulus z। ठीक है, ये हो सकता है स्क्वायर रूट लेने से। एंड डी ऑप्शन क्या दे रहा था, नॉन स्क्वायर। सो ये क्या है, कुछ प्रूफ बेस्ड क्वेश्चन थे, ठीक है। एक और क्वेश्चन मैं लेता हूँ, सिंपल सा है। सो इसका क्या निकालना है आपको, अपर बाउंड्री निकालना है, ठीक है। देखते हैं क्वेश्चन क्या है। यहाँ से ये प्रूफ हो गया ना आपको, तो मिल गया आपको कौन सा ऑप्शन, करेक्ट ऑप्शन। स्क्वायर रूट लेने के बाद से ये पहला वाला करेक्ट ऑप्शन हो गया आंसर, ठीक है। नाउ मूव ऑन द नेक्स्ट क्वेश्चन। क्वेश्चन है कि यदि मॉडुलस z बराबर के लिए क्या फाइंड करना, फाइंड द अपर बाउंड इसका, वन अपॉन जो के पावर 4 माइनस जेड स्क्वायर, 4z स्क्वायर से क्या है, जेड के पावर 4 माइनस 4z स्क्वायर प्लस 3 अगर है उस टाइप का, तो इसका अपर बाउंड कैसे निकालेगा। तो सबसे पहला काम क्या कर रहा हूँ, जो डिनोमिनेटर है उसको ब्रेक करो। इसमें सिंपल क्वाड्रेटिक फॉर्मूला पहले क्या है, ये जेड के पावर 4 है माइनस 4z स्क्वायर है प्लस 3 इक्वल टू 0। देन इसको कैसे लिख सकते हो, जेड स्क्वायर माइनस 1 और सेकेंड जेड स्क्वायर माइनस 3 लिख सकते हैं ब्रेक करने के बाद। सो अप्लाई कर सकते हैं यहाँ पे, क्या है ये, जेड स्क्वायर माइनस 1 एंड जेड स्क्वायर माइनस 3 अप्लाई कर दिया गया। मॉडुलस को ब्रेक करना है, देन मॉडुलस को ब्रेक करते हैं, सिंपल सा है। सो पहले सेक्शन में क्या करो, सिंपल, जैसे कि अगर मैं मॉडुलस जेड इक्वल टू 2 ले लेता हूँ, ठीक है, क्योंकि अगर इसको सॉल्व करोगे, सो मॉडुलस जेड स्क्वायर माइनस 1 विच इज इक्वल टू व्हाट, विच इज ग्रेटर इक्वल टू मॉडुलस जेड स्क्वायर माइनस 1 विच इज इक्वल टू 3, ओके। एंड second thing is that जेड स्क्वायर माइनस 1 है, ओके। एंड second thing is that कि अगर जेड स्क्वायर माइनस 3 है लेस और इक्वल टू मॉडुलस जेड का स्क्वायर माइनस 3 विच इज इक्वल टू 1, ओके। एंड जेड के पावर 4 माइनस 4z स्क्वायर प्लस 3, सो ये क्या हो जाएगा, ये हो जाएगा 3.1 इक्वल टू 3। सो यहाँ से आपको अपर बाउंड क्या निकल के आएगा, 1/3 हो जाएगा, ठीक है, क्योंकि 1 अपॉन में है ना, तो 1/3 हो जाएगा। उसी टाइप का एक और क्वेश्चन यहाँ से अपर बाउंड निकालना आप सीख गया है, तो एक और क्वेश्चन समझे। वन मोर क्वेश्चन है, जैसे कि फॉर ई ग्रेटर देन 0 है, ओके, इसमें अप्लाई कुछ होना चाहिए, ठीक है। क्वेश्चन एक बार समझते हैं, ये थोड़ा अच्छा क्वेश्चन है, एक और क्वेश्चन समझते हैं। नेट लेवल का है, ठीक है। और कॉम्प्लेक्स नंबर Z1 Z2 Z1, ठीक है। द जनरलाइज्ड ट्रायंगल एंड ग्रुप्स मॉडुलस Z1 प्लस मॉडुलस Z2 प्लस डॉट 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 मॉडुलस Z1 इज व्हाट, ठीक है। देन इसका सॉल्यूशन पे आते हैं, ऑप्शन आपको दे रहे हैं, ये ऑप्शन ये है, मॉडुलस Z1 मॉडुलस Z1 प्लस मॉडुलस Z2 प्लस प्लस मॉडुलस Z1। बी ऑप्शन है एन मॉडुलस Z1 प्लस मॉडुलस Z2। सी ऑप्शन है मैक्सिमाइज ऑफ मॉडुलस Z2। डी ऑप्शन है एन डॉट मैक्स। ये ठीक है, ये ऑप्शन है। सो सॉल्यूशन क्या होना चाहिए इसका, उसको समझो ध्यान से। क्वेश्चन क्लियर है आपका? दिमाग कैसे लगाना है इसमें, कैसे करोगे? तो क्या दिया हुआ है क्वेश्चन में कि दिया हुआ है कि कोई कॉम्प्लेक्स नंबर है जब जबकि उसका जनरलाइज दिया हुआ यहाँ पे फॉर्मूला दिया है। ठीक है। सो आपने एक चीज दिमाग में लेके आनी है कि मैथमेटिकल इंडक्शन सिंपल है। सो भाई मैथमेटिकल इंडक्शन एंड द ट्रायंगल इनइक्वालिटी मॉडुलस z क्या होगा, लेस और इक्वल टू मॉडुलस h प्लस मॉडुलस y। ओके। सो सिंपल है कि अगर दो रहता है आपके पास में जब प्लस डब्ल्यू, ये दोनों मान लेते हैं सब तो इसको आपको सिर्फ जो है मॉडुलस z प्लस मॉडुलस डब्ल्यू लिखते हैं, है ना? देन we get these things, what मॉडुलस z1 मॉडुलस z2 मॉडुलस z3 डॉट डॉट मॉडुलस z1 लेस और इक्वल टू मॉडुलस z1 प्लस मॉडुलस z2 प्लस मॉडुलस z1। ओके। सो दिस इज fundamental result used for throughout complex analysis। So I think इसको मैं दे देता हूँ आपको होमवर्क में। सिंपल है, इसको समझने का प्रयास करें क्या होगा क्या नहीं। ठीक है। सो थैंक्स फॉर वॉचिंग दिस वीडियोस। मिलते हैं नेक्स्ट वीडियोस में और भी क्वेश्चंस के साथ में। कुछ और भी है जैसे कि सिंपल सिंपल से क्वेश्चन है ना, तो उसको मैं नेक्स्ट क्लास में करवाऊंगा। बट अभी के लिए इतना ही रहने देते हैं क्योंकि टाइम बहुत ज़्यादा हो गया है। ओके।